and welcome to this BCS, the Chartered Institute for IT interview. Today I'm with Professor Sir Nigel Shadbolt from the University of Southampton, the Professor of AI. Thank you, Nigel. Thank you for joining me. Now, I was wondering if we could kick off really on what you're working on at the moment. What sort of things are you up to?
So a lot of my interest currently is really, you might think of it as AI in the web and on the web. I've been working for the last 10 years in the area of the Semantic Web. Okay. And interestingly, this is all about trying to put more intelligence, more meaning into the web. And it draws on a whole range of methods from AI historically. Knowledge representation languages, for example. How do you code for meaning and then embed that within web pages? Other aspects would involve the use of intelligent agents as various providers of services on the web. Right. So the surprising thing about the modern web is that there's lots of AI pervading it in the background, from natural language translation, when you see your Google Translate results, through to some of the underlying search methods, recommendation systems, and in that sense, a lot of my AI interests are in that space now. I have an ongoing collaboration with a colleague in the area of computational neuroscience, where we're essentially trying to understand models of how actual brains and nervous systems work, and where we can think about deploying them on robot platforms. That's somewhat of a minority interest at the moment, but as I say, my AI interest historically started out in computational linguistics, moved into expert systems, and then now into this whole area of AI in the web. Okay,
so with that in mind, what sort of challenges are you foreseeing over the next few years, or what have you?
In AI?
In AI, yeah.
Well, the challenges I think have to do with, well, one thing that people observe all the time is some of the inevitable laws of our discipline. So Moore's law, the increasing power at our disposal, increasing memory densities available at our disposal. These create devices and systems which can solve problems that we didn't think could be solved using a mixture of brute force and a little insight. I think that's the way I've often seen AI advance, is quite a lot of brute force, but an exquisite application of insight about the way in which you can use intelligent search methods or the methods from AI to produce a really powerful product. So that I think the challenges there are this data deluge that we're seeing as well. So the increasing speed and power of our machines means that we can simply emit and generate more and more data, and this whole development of the Internet of Things is so a flood of data, and quite obviously quite a number of the techniques of AI, from data mining, machine learning, are going to be deployed in this context, trying to find the signal in the noise. Other challenges will undoubtedly have to do in other areas of AI deployment. They'll have to do actually with the fact that social and demographic changes are meaning that where we might think about deploying AI in the future is going to be rather different. One obvious example is elder care, looking after an elderly and aging population. AI-assisted elder care is very much an area that's going to get bigger and more interesting. And the obvious ones that people know about, of course, cars that drive themselves, autonomous vehicles, the really steady progress of work in this area. And if we go back to some of my original interests in systems like in areas like expert systems, I think it was a big shock to people when Watson defeated the world's best Jeopardy player, this US game show. Because what you saw there was apparently very powerful general knowledge, and it's always claimed that AI would never solve the general knowledge problem. But in fact, it hasn't solved the general knowledge problem. What it's done is use large-scale knowledge assets to solve that particular game show format in a really powerful way. And I think what people are looking to do there is extend those sorts of methods into areas like medical consultation, where if the general information was about the medical domain, could you apply those same methods? Another area where there's been powerful developments in machine learning, undoubtedly Bayesian methods, for example, this whole idea of using probability and powerfully reasoning with probabilities yielded very powerful insights. Okay.
So going on to, you touched on about development of sort of AI replicating the brain. I spoke to Grady Booch not long ago. I mean, it's one of the sort of things that he sort of touched upon. Yeah. Where do you think we are with that? Do you think it's in any way possible, or is it just sort of that bit further over the horizon that you don't know?
Well, many people see AI as building a brain in a box, or a Terminator, some humanoid robot killer. In fact, I think as AI professionals, we have to always ask ourselves the question of whether our technology is actually being applied ethically, and you see this now when people think about drones and remote management of weapons systems, and who's giving the release of those weapons or the targeting permissions. Is that a program or usually a piece of AI or not? But the bigger question about whether we can build a faithful simulation or some replication of the human brain, in truth, it's extraordinarily hard. What we have in some areas are really high fidelity simulations of the complexity of the individual nerves that make up the neurons that make up the human brain. We can put those together into smallish circuits and appear to do quite interesting things. But what we're learning as we learn more and more about the brain itself from neuroscience is how exquisitely complex that is, and how we have parts of the brain specialized in to particular capabilities, whether recognizing your face, a bit of the brain whose sole capability is to recognize human faces. That piece of the brain gets damaged, you can't recognize people's faces, you don't know who you're talking to. Through to the ability to represent space and place in parts of our brain, so the maps we're able to build, literally the mental maps. We're understanding quite a lot about that, and we can take bits of those insights and implement those as quite decent computational programs. And then the question is, if you put those inside a robot, you get a better result, or would an engineering solution that didn't use anything like a human approach to the problem serve a better result ultimately? And I think that's what's very interesting about this area is, in some sense, the toolbox of methods that AI is offering go beyond, of course, what evolution has produced and provided. And we may well end up building devices which are some kind of blend of methods that we've taken and drawn insights from in psychology and methods that have come straight from the engineering toolkit.
Because you started to touch on the philosophical side of it. How do you think as a society we're ready for that sort of discussion? You know, you start touching on Asimov's laws of robotics and things like
absolutely.
that. So
yeah, it's come about much faster than you might have imagined. I mean, that's a great thing about science, and in particular the future. A science fiction writer, William Gibson, who said, the future is already here, it's just unevenly distributed. So if you look, you will see the foretelling of or the foreshadowing of a significant problem that society is going to have to deal with. So when you see these discussions around what is the policy for remote deployment of weapons on pilotless aircraft, you're really into just that question. What are those behavioural principles or moral principles that you're going to effectively code into your programs?
Because there's the whole thing with you said about the self-driving cars. I mean, Google basically announced that they had self-driving cars after they've been driving them for a period of time, didn't they? And everybody, there was a sort of a wow and a shock factor to that.
Yeah, and sometimes it's better to seek forgiveness than permission, you might say, in these areas. The same thing is actually happening with Google Glass, of course, where this device is going to be capable of capturing huge amounts of information, experiential information. You wear this device and you're essentially storing those things that you've observed in your visual field. Well, you'll observe all sorts of things accidentally that might in future serve to embarrass or compromise or in some other way infringe other people's interests. So what kind of assumptions and behaviours and social norms do we... And it is interesting how very often the questions around AI come back to questions about ethics and social norms. Are we happy to have everybody recording everything that's going on in the pub of your choice?
Yeah, exactly. Now you touched upon the Terminator thing. Obviously, that there's when people start talking about AI, the whole sci-fi thing starts to come in, and people think, does that have a negative impact? Do you think on the discipline?
I think for a large number of us, we got into the discipline because we were reading those sci-fi novels. I mean, I was absolutely gripped by the Asimov novels and a whole variety of writers in the area of robotics and AI, and it certainly kind of ignited my imagination. I think it was true for a number of my colleagues, and I think it remains to be true. Now, the Hollywood projection of these devices and how AI is used, it actually falls into two rather clear camps and not very nuanced. There's either the robot as friend and companion, lovable, cuddly Teddy in the Spielberg AI film, or it's a very different image of, say, Terminator and or HAL in 2001. And I think that increasingly the reality of AI is both more impressive and more routine than people imagine. They simply have no notion of how much AI is already embedded in software and devices, routinely being applied, because people don't think of AI as a method for doing optimization or constraint satisfaction to make your car run smoother, or your wash cycle in your washing machine be more efficient, or autofocus in your camera be crisper. That's not AI, because it's not talking to you and having a schizophrenic breakdown, but actually it is a method directly from the AI catalogue.
Yeah, it's funny when you think about that, you wouldn't necessarily assume. And what sort of, you touched on some of the areas that you think AI could be used on. Are there any other areas? I mean, you were effectively saying about big data and using AI to analyse it and get real value out of that. What other areas can you see AI moving into, or would you like to see it?
Well, they already are. I mean, I think, again, AI has historically focused on both generalised application, but also specific sectors. So medicine's always been an area of specific application. Decision support systems now in a whole range of clinical settings. Systems that are able to take patient case data sets, look for patterns in them, look to help provide recommended advice to clinicians who are always in a state of being too busy, with too little time, too much information. And so it's quite routine now to see software support systems helping people in those kinds of contexts. And this is what holds for medicine, holds in areas of finance, retail, logistics, educational delivery.
But then, of course, the minute you start saying medical records almost and computers, people start to panic that they won't be secure and it'll be leaks and things like that.
Absolutely.
So do you think we're going to need to evolve a different level of trust in the systems that we don't currently have?
Yeah, I mean, I think that very much speaks to one of my other, if you like, core area of research and activity at the moment is in the whole area of open data and how we use open data and the data assets that we're getting released by government. And some of that will be not just open, it'll be personal data. And you've got to really be very attentive to respecting what is personal, what might be identifiable information, putting boundaries around that, working out whether you can actually secure it, make it remain anonymous. And in general, I think it isn't always a technical solution we're looking for here. It's a social convention, it's a norm, it's sometimes legislation that says just because you can use this data to identify someone doesn't mean you are free to do so. And if you do it, you will be held accountable. So we're living in this, and AI, is some part of a contributor to this, because a lot of the facial recognition algorithms come straight out of AI. We're living in a surveillance culture, people say, or the end of privacy. And we do have to have this conversation that just because, there's this lovely term, we have reached the end of practical obscurity, you can't hide your face in the crowd now, doesn't mean that anything can be done with that information. And we're seeing now in the debate around PRISM and the NSA data analysis, there's huge power and analytic capability out there, but how are we going to hold people accountable for what is done and whether that's a proportionate good that is done? Because you can give you the possible downside, but on the other hand, it can give you lots of upside in the area of large-scale data analysis to work out disease trends and patterns in the population.
Now you touched upon at the start your work on the Semantic Web and what you've been doing. Where are we with that? Because obviously, I mean, people like yourself, we've been talking about it for a number of years. And where do you see it being at the moment?
Well, I think actually the Semantic Web represents also a feature of AI, is that when the original vision is articulated and put forward, it's usually quite bold and grand, and that's quite helpful in terms of getting people's attention, also motivating people. But what invariably happens is the bolder vision, the grander ambition, is very difficult, really hard. And what tends to happen is a simplification of the ambition, a radical simplification of the methods and techniques used to tackle the problem, and a thin residual element of the original proposal lives on, gets implemented at scale, and makes a difference. And I think that's where we are with the Semantic Web. The original vision of this web of intelligent agents that would kind of anticipate your needs and ship this content from this place on the web to this place on the web, or get stitched together, this is very hard. I mean, it's still a very hard AI problem. And what we have now is we actually prefer it to it, actually not as the semantic web, but the web of linked data, where we have some basic principles that allow us to identify data where it occurs on the web using web addresses, dereferenceable web addresses, stitch that together, query over it, and treat the web in some sense as if it was a large distributed database. Now that offers really powerful insights, and the places you start to see this emerge, if you go and do a Google search on an individual, me for example, type in my name, you'll see a right hand box there with a bunch of information about me that's been stitched together using the kind of Google knowledge graph format, and that's essentially an AI representation of the information known about me from across the web, or some of the information that it's choosing to present about me from across the web.
Because I remember reading an article about the Google algorithms, because obviously it can just search certain words, but then it's knowing when certain words are names and when it's a question, isn't it? It's the interpretation, like one of the first things you touched upon, isn't it?
Oh, that's really hard still. We've made real progress. I mean, the state of computational linguistics itself, when I was beginning in the field of AI, approached the whole problem of understanding language in terms of grammar-based formalisms, ideas from people like Chomsky about how language was structured and worked. There were real difficulties in getting extended data sets about the use of language, data dialogue. And then the web came along, and now we have huge resources, massive numbers, billions of pages of written English, huge extended amounts of interaction and discourse of people, different languages on social media sites. That would have been a hugely expensive resource to have built just 30 years ago. Now these resources exist, then the techniques from AI, large-scale statistical parsing, they are applied, and they can really do a remarkable job about identifying the names of individuals, dates, places, start times, end times. Other things are harder. It's harder to find the relations that link the terms together. It's harder to find the underlying background information that often sits in a piece of natural language text. We did an experiment actually in my group a few years ago where we were trying to look at scientific literature. We would take all the abstracts from these various papers and try and analyse them and build graphs and represent the content of what these papers were about. The trouble was, huge amounts of background information were required to make sense of those abstracts.
Right.
And that wasn't in the language. You and I as an expert in that field would recognise it, but it just wasn't there. So these still remain deep challenges for AI.
Yeah. And is it just going to be time? I mean, or is it a matter of more computational power? Or
I think that's where the Watson, coming back to the Watson example, is quite interesting, because there what you're seeing is the federation of a whole lot of knowledge-intensive modules together to try and get behind this problem. What is the background knowledge you need to make sense of an abstract, or to make sense of a question in a game like Jeopardy? And they're able to do that now, again in part because of the web. You have Wikipedia. Because of the web, you have all of the world's literature online. You know, in certain genres. You know, the Bible electronically indexed, filed, and organised. And these assets then become something that you can interrogate in a principled way, seek to learn patterns for, seek to derive insights from.
Yeah. So, what's next?
They always say that making predictions about the future is somewhat dangerous. Actually, even predictions about what you think you'll be doing in 5 years' time can be a bit fraught with uncertainty. I think that we know some things for sure, so we can use those graphs about how much computer power we're going to get and how much memory density we're going to get and the number of devices that will be available with a web address. And that helps us, I think, see a world emerging where there is huge amounts of connectivity, huge amounts of data portability between devices. I think we'll see more and more opportunity for systems that deliver in real time advice and guidance about the decisions we're trying to make, the bus we catch, whether we should choose this product over that product on a supermarket shelf, and more than that, actually anticipate our intentions from what we do. Our intentions can get anticipated, so that the system's actually suggesting that you might want to consider doing this next, or actually following this course of action, or you've been leading this kind of set of activity during the day, you might want to consider doing something else. We're seeing this actually in devices in areas like I wear this device, we're going to track how many steps I've taken during the day. Apparently it was quite cool. I'm told it's becoming quite naff now, but there you go. You can never stay up with technical fashion.
Well, quite.
But this whole area of monitoring and cataloguing data from our own everyday experience, this life logging areas it's called, it's going to be very explosive, I think. So the sheer amount of data we generate and carry around about ourselves, and of course our mobile phones do just this as well, will be really interesting data sets for all sorts of subsequent analysis. And I see, so for example, in health management, well-being management, illness management, we're going to see increasingly a situation where medical practitioners will expect you to have rather an extensive data log about your lifestyle, what you've been doing. And this, people can get alarmed and think, oh, this is all going to be kind of database state stuff. But there's an opportunity here for helpful intervention, for predictive maintenance. We do this already for jet engines. Rolls-Royce has algorithms to work out when that jet engine may go wrong. Okay. We may well start to find those same techniques being used on ourselves.
Sort of analysing, we've noticed that you're not quite walking as fast as you were 3 weeks ago.
They're doing this for high-class athletes at the moment. They watch how they run on the park, do some data analytics, and work out this person may get a hamstring pull any time now. And these are powerful methods. So that whole area of data analytics is going to be explosive, I think, and AI will be at the heart of that. We're going to see more, if you like, of the classic mobile robotics. I think we'll see more of that because there's more power. We're talking about driverless cars now. I think they'll become increasingly a fact of life. And again, routine instrumentation of devices where we hadn't even thought there was a point in putting a computer into them will happen, whether it's our kettles or our, we're already seeing with electronic white goods, but we'll see it across a whole range of other devices.
We're sort of talking Internet of Things.
Yeah.
So a lot of this comes down to, like you say, an aggregation of data. Of course, you've immediately got the security angle on this. Do you think we are there yet? I mean, do you think we need to go more to a transparency model, anonymization of all data?
I don't think there's a single answer to the challenge of what you do with this flood of data to ensure both security and privacy and appropriate levels of protection and accountability. It won't all be technical, it won't all be social, some of it will need to be legal, some of it will need to be ethical guidance. But this will emerge simply because we're being confronted by the challenges now. And I think AI is increasingly, and more generally computer science, will find itself, and the web, the web internet giants will find themselves in the dock of public opinion about some of the developments. That's as it should be. Technologies, as they become impactful and powerful, generate a social debate. And actually, organisations like the BCS have to be at the heart of that debate.
So in terms of AI, AI always gets bundled in with robotics. Do you consider that? They obviously do they work hand in hand? As a layman.
AI isn't just robotics. Robotics is a very compelling and it grabs the attention. There is this device, and it's in some sense doing usually something interesting. Many of the programs and algorithms running on your tablets or your PCs, they're just not as engaging. But when you get this kind of Atlas robot that's being built and shipped over literally in a coffin to be resurrected, people go, oh my God, what is this about? We are really starting to see the realization of a classic vision of robotics. I think in truth, a lot of robotics will be devices which you think, oh, what's that gizmo doing? Would you think you'd have needed a device to go crawling down the drains, or one to kind of crawl through the forest looking for kind of infectious diseases on trees? The range of deployment modes and how we'll build devices to support those will be very broad and wide indeed.
Now, obviously, I'm sure you would have seen in the news this week, there's been a pilotless F16, I think, plane. That's obviously a step on from the drone. I just wanted to tap into your thoughts on that. It's obviously an amount of AI in that system.
Sure, and there always has been in avionics.
Of course, the whole fly-by-wire.
Yeah, and the truth is that without a lot of that avionics, a lot of it AI-based, pilots wouldn't be able to fly their planes for quite a long time now. The fact you can now take the pilot completely out of the system you ask yourself, what is the human in the loop there to do? And actually, very often it's to exercise judgment, judgment about the right thing to do, the right action to pursue. And that's still, even in the pilotless case, you'll have some remote operator as a human taking and making those sorts of judgments. So, no, I mean, I see this as a continuation.
Because the drones, because they say they don't actually, it's an operator who fires the weapons.
Yeah, at the moment. But of course, the question will be, what are the rules of engagement? And would you imagine rules of engagement where, because of speed of response, latency times, this is literally an arms race. And as the adversary gets quicker to respond, then the decision loop, the cycle time you have to make a decision, may get to the point where it's beyond, and if you like, the cycle speed of the human operator to deal with it. At that point, what do? Do you give permission to the system to defend itself? Already happens in fighter planes where they look to deploy chafe, countermeasures. The systems on board do that in the presence of many times in the presence of incoming threats.
And of course, in banking, a lot of the banking systems that obviously these trades are done on nanoseconds, aren't they?
Yeah.
I think a lot of that is done through automated
Yeah, that's right.
systems
So you've got to have an automated system, but what you still then need is some overall guiding precepts, such that you can say, this system is now in free fall. We pull the plug and revert to something more at human speed.
There's a member of the Irma group, John Mitchell, who often says that the next war will be won by whoever's got the fastest computers. Could it be whoever's got the best AI?
It's going to be part of it. The fastest X can be a lot of things, from the fastest optical relay connects through to the fastest cycles through to the best AI or the most data. It'll be a combination of all of those things, or indeed a trained workforce able to put this stuff to work at all. So in all of this discussion around AI, a key feature is, do we have the human capacity and capability to exploit this technology, develop it, invent it, and execute it?
So do you think there needs to be a wide level societal sort of discussion on the application of AI, in terms, because we talked about obviously patient records and things like that. Do you think, because people, we have debates about whether the UK should be in Europe and things like that, but this is on a much bigger scale, isn't it?
I don't think it makes a lot of sense to talk about AI in those general terms. I think what we will see are occasions when we want to have a discussion about particular facets that possibly AI has led to, or that AI is involved with. So we talked about this in terms of autonomous control of weapons platforms, or the issue around the ethics of surveillance and the appliance of AI algorithms in those contexts. And I think then you want the questions to be occasionally broad, but sometimes quite specific about the merits and demerits of the technology.
Because you're always going to get the scaremongers, aren't you? Actually.
Yeah, you are. I mean, and it's important that we also understand the limits of our technology. So before you get too enthused about the application of a particular method in a domain, so for example machine learning methods in medical domains, you really want to be assured that sufficient is known about the characteristics of that algorithm to confidently deploy it. And I think that's where in all technology you want to have those kind of assessment processes. Whether you need a bigger debate in society about some of these questions, I think that will depend on the challenge you're looking at.
Brilliant. Nigel, thank you ever so much for your time. That was excellent.
Pleasure.
I really enjoyed that.
Good to talk to you.